All right, so this is the second example, E2, from our notes. All right, so in this case, again, you want to look at the exponent here. And since it is a 4, I have to look at the fourth row of Pascal's triangle. And the fourth row has the numbers 1, 4, 6, 4, 1. So if I come back here, I'm going to write those numbers out and leave a little bit of space in between. 1, 4, 6, 4, 1. All right, now starting with the first term, it's an x, and you always raise whatever that first value is, it's going to be raised to the matching exponent, and then you're going to drop by one exponent for each term that you write. So this would be x to the fourth, x to the third, x to the second, x to the first, and x to the 0. And the second term, you're going to do the opposite as I did here. So I'm going to start with a 0 exponent and work up to the fourth exponent. But be especially careful when you have negatives. You have to include the negative in the parentheses here. So it's -1 to the 0, -1 to the first, -1 to the second, -1 to the third, and -1 to the fourth. Zoom out a little bit. There we go. All right, so now I just need to simplify each one. So this becomes 1 times x to the fourth, and any base raised to the 0 is a 1. So this would equal x to the fourth. This is 4 times x cubed, and -1 to the first is a -1, and I have to multiply the 4 and the -1, so that becomes -4x cubed. Here I have 6 times x squared. Well, a -1 squared is a +1, so that becomes plus 6x squared. Here is 4 times x. A -1 cubed is a -1, and that's -4x. And here I have 1 times x to the 0 is 1, and -1 to the fourth power is a +1, so this is going to be +1. So here's your final answer for example 2.